In 1985, two young physician scientists from the University of Texas Health Science Center in Dallas, now known as UT Southwestern Medical Center, won the Nobel Prize in Physiology or Medicine. The Nobel Prize was a first for Texas science, but more importantly, the work of doctors Michael Brown and Joseph Goldstein unlocked the secrets of cholesterol metabolism. Ultimately, it led to the development of life-saving statin drugs for heart disease, an event that's been called one of the most important advances in modern medicine. Brown and Goldstein's story is one of unwavering diligence, dogged persistence, unrelenting focus, and an unlikely partnership that has lasted more than 4 decades. In several respects, Mike Brown and Joe Goldstein couldn't be more different. Brown, an extrovert, was born in Brooklyn and grew up outside Philadelphia. Goldstein, quiet and reserved, was born and raised in a small South Carolina town. Yet, despite their apparent differences, Brown and Goldstein would quickly discover they shared common ground.
Joe Goldstein and I met when we were residents at the Mass General Hospital in 1966. He had been a medical student here at UT Southwestern, which at that time was the nation's youngest medical school, and I was a student at the University of Pennsylvania, which was the nation's oldest medical school. Within a day or two, it became clear that Joe was smarter than anybody else, certainly in our residency group, smarter than most of the faculty, and really knew a lot of medicine.
We were not on the same rotation until about 3 months later. We were in the emergency room together. So Mike, that was the first time that I really had contact with Mike Brown.
What drew us together was our common interest in science. And Joe and I used to just strike up conversations, and we, instead of talking about the practical matters of the patients, because that had already been done, we talked about the underlying pathology. Why should this patient get pneumonia at this time? Or why does that patient have arthritis? We just found that we just enjoyed talking about science. And then by chance, we both were accepted for research positions at the National Institutes of Health.
In those days, after your internship and residency in medicine, you had a choice. You could either go to Vietnam or you could work at the NIH and have a deferment as a member of the U.S. Public Health Service.
At the National Institutes of Health in Bethesda, Maryland, Goldstein would soon come across an astonishing case. A 6-year-old girl and her 8-year-old brother who were having heart attacks and had extraordinarily high cholesterol.
About the second month I was there, one of the patients I was assigned to work up were a brother and a sister actually from Texas. And they had what we now know as homozygous familial hypercholesterolemia, where the two children had cholesterols of 800 to 1,000, whereas the normal for a child should be about 150. This was probably one of the most striking moments in my life, is to see this child and work this up and learning about this disease. So I think within probably a week I told Mike about it.
The little girl was 6 and her brother was 8, and they were both having heart attacks. And that really attracted us, and we began to try to think about why it is that what kind of a mutation could give you such a high cholesterol level so early in life. We never went into this with the idea that a treatment would come out of it. We did it because it was a puzzle that to try to figure out why these children had such high cholesterol levels. We thought, well, maybe if we can understand this rare, and it was a rare disease. Remember, the children are only 1 in a million. So a lot of people would say, well, why waste your time on something that's so rare? Study a common disease. But we felt that if we could understand why these children had such high cholesterol levels, that it might help us understand why garden variety high cholesterol occurs.
So anyway, we just kept talking about these patients, and it sort of evolved. He knew I had this job to come back to Dallas. So I stayed at the NIH 2 years and then went to Seattle to learn medical genetics, and then was coming back to Dallas in 1972.
So Joe had promised to come back here after his training and start a genetics program, and he kept trying to convince me to come and join him.
So I talked him into it, got him to meet Selden at a meeting in Atlantic City, and he was intrigued by Selden. He had never seen anything quite like him.
Dr. Donald Selden, a retired professor and former chairman of internal medicine, first came to UT Southwestern in 1951. Selden had a keen eye for spotting talent, and he began recruiting a team of outstanding young researchers and physicians, among them Joe Goldstein.
First of all, Joe was omnivorous. He knew all of medicine and was appalled if some obscure thing escaped him. He was full of zest and verve and sparkle and was driven to accomplish something that was noteworthy.
When I met Dr. Selden and the faculty here, I was just absolutely amazed at how focused they were on the science of medicine. Everyone on the faculty was a scientist as well, and so the level of discussion about patients' problems and diseases was, frankly, at a much more sophisticated level than at Harvard Medical School. It's pretty shocking, but it's true. I came here directly from the NIH, so I actually arrived a year before Joe did, and I started my own project, and when Joe came here, he had his own project. So we had separate laboratories, separate projects, but we decided to collaborate on this one project to try to solve the problem in these children.
Alice Brown has been married to Mike Brown for more than 45 years. Childhood sweethearts, she and Mike planned only a brief stay in Dallas. Soon, those plans would change.
Really, we rented a small house for 1 year. And it was only towards the end of that year that he thought we might stay another 3 years, just because their research seemed to be going so well.
Dr. Susie Dana, a forensic pathologist in South Central Texas, was a lab technician in the Brown and Goldstein lab in the early 1970s as their research work was intensifying.
Dr. Brown had probably one of the most analytical minds I've ever encountered in my whole life. There was a time once when I came up with this little logic question, and I thought, I was finally going to stump him because he was always so brilliant. And I gave him the logic question, and then I had to go do something, so I went away for a little bit. But when I gave it to him, he just kind of stared at me, never said a word, and started pacing back and forth and back and forth. And then when I got back in about 5 or 10 minutes, he comes up with the answer, and I was just blown away. I thought, how in the world? I mean, this was supposed to be an unsolvable logic problem, and he solved it in probably about 10 minutes.
But there's a difference between the two of us, and I illustrate it, it was striking. Again, in the old days when we used to work in the laboratory, we'd frequently have to go to a microscope to look down at the cells. And we'd go to the microscope, and if I were the first one, I would dial it up to the highest magnification so I could see the real details of the cells. And then Joe would walk up to the microscope and immediately dial down to the lowest magnification so he could see the whole pattern of the cells. And I think that illustrates a difference in the way we tend to think.
If you look at high power, you see a lot of details, but you also miss the big picture. And if you look at low power, you see the big picture, but you miss the details. So that's an advantage of having two people work together, because you can then get everything.
As this partnership sort of gradually developed, it didn't happen overnight that we signed some contract, but as we began to be more and more comfortable working together, literally planning the experiments together, sitting over a pad and planning the next day's experiments and arguing over exactly how to do the experiment. As that developed, we realized that there was no way that either one of us could take individual credit for anything that happened.
In the spring of 1973, after months of experiments trying to solve the puzzle of cholesterol metabolism, Brown and Goldstein performed yet another experiment, but this one produced a remarkable result.
The Eureka moment experiment was one in which we were looking at the enzyme that controls cholesterol synthesis in a fibroblast from a normal person and a fibroblast from one of these children with this homozygous form of familial hypercholesterolemia.
There was one day in 1973 when we knew we had made a big discovery.
We designed this experiment, and then this technician, Susie Dana, did it, and I don't know whether she really understood.
I was there when the results came off, and it looked like, oh, hey, something's happened here, and it looks, good. I thought, this is kind of interesting. But I didn't realize the significance of it, probably.
The amazing finding was that when the cells were grown in there with lipoproteins in the serum, there was about 200-fold increase in the cholesterol synthesis enzyme from the girl that had the familial hypercholesterolemia compared to the normal individual. And it's very rare that you see a difference like this.
And Dr. Goldstein came back and was just looking at the results and just bouncing off the walls almost and saying, do you know what this means? Do you know what this means? And I kept saying, well, yeah, it looks like it worked, and I'm going through the whole thing. And so he was just ecstatic.
But it wasn't, when I looked at it, I couldn't believe it. And actually I ran in Dr. Selden's office and Mike wasn't there.
Well, it happened on that day. I was in Atlantic City, New Jersey, giving a talk at a meeting, and Joe was here in Dallas. When I got back to my hotel in the evening, I had a message that said, call Joe Goldstein at this number. So I get Joe on the phone. He says, you can't believe the experiment. I said, what are you talking about? He said, well, Susie, the technician, came in and showed me the data. It's unbelievable. I mean, the patient's cells have activity of the enzyme that's 100-fold above normal. I really questioned her. There's no question that, she did the experiment right, but, maybe it's some fluke. Of course, we have to repeat it. But if it's real, we have an incredible discovery.
It was a hypothesis up to that point, I think, but now they had concrete evidence that they could actually show that it was working.
Brown rushed back to Dallas, where he and Goldstein would embark on a particularly intense period of work.
We started this system where we planned every experiment the day before. So we'd get the results of an experiment in the afternoon, and then we'd plan the experiment for the next day. And we had a system where every experiment just could be completed within one day. So we'd get the results, and then we could do the next experiment. My oldest daughter was born on June 1st, 1973. That was right in the middle of all this excitement. We had just done the experiment that I've been talking about, and we were so excited about it and planning all these experiments.
Michael and I joke that our first daughter was born June 1st, 1973. I was in labor, and he kept running back to the lab because some very exciting things were happening. And I was at St. Paul's Hospital, which is just across the street from the lab. He would come in, see how I was doing, run back to the lab, not telling me anything that it was that exciting. It was like, you could spend one day in the hospital.
Additional experiments would further refine Brown and Goldstein's work, revealing in 1974 a molecular mechanism, previously unknown, that turned out to be the key step in cholesterol regulation in the body. They discovered a receptor molecule that controls the level of cholesterol in the blood and in body tissues. When the gene for this receptor is faulty, it causes people to suffer cholesterol buildups earlier in life than others. Cholesterol is normally transported in the blood by lipoprotein particles, of which one major group is low-density lipoprotein, or LDL cholesterol, an important risk factor for heart attacks. The gene Brown and Goldstein discovered controls LDL receptors on the surface of liver cells. The liver is the gatekeeper of LDL cholesterol levels and is responsible for its removal from the blood. LDL receptors on liver cells draw the bad form of cholesterol out of the bloodstream to meet the cell's individual needs and get rid of the rest. When there aren't enough receptors to do the job, LDL cholesterol accumulates in the blood and eventually narrows arteries, increasing the heart's workload and the chances for heart attack or stroke. The discovery by the two young physician scientists in Dallas took the scientific world by surprise. Dr. Daniel Steinberg, a noted pioneer in the field of cholesterol, was one of the first to learn of the breakthrough developments when he was approached by Goldstein.
I was the chair of a workshop, a series of papers on lipoproteins, and this young man came up to me and said, we think we've found the molecular defect in familial hypercholesterolemia. I said, tell me about it. But their findings were so clear-cut, and the work was so elegantly done that one had to believe it. The work that they did in the 70s shaped the future of research in this field, without question.
But not everyone would embrace Brown and Goldstein's discovery, or even the value of trying to lower cholesterol.
This is the 1970s, and there was tremendous skepticism about the importance of blood cholesterol as a cause of heart disease. Even though some of us were totally convinced and had been for some time, and I think maybe a majority of the people who actually worked in the field were convinced. But the skepticism was rampant.
I remember him being very discouraged because the results were so unusual. People were attacking them as being either poorly done, experiments, or, I don't know, misinterpreting the data, something like that.
Brown and Goldstein's work did attract the interest of a Japanese scientist, Akira Endo, who independently had been trying to develop a cholesterol-lowering drug, known today as statins. Endo's focus on finding an inhibitor of cholesterol synthesis in liver cells would pay off, and Brown and Goldstein's discoveries would help explain why. Major drug companies were also interested in cholesterol-lowering medications.
Everyone should understand that Joe and I did not discover statins. The discovery was made by a Japanese scientist, and the commercialization was done by some very courageous scientists at Merck. But we did explain the mechanism by which the statins work.
And several drug companies are already working on medical ways to increase receptor formation. It's been shown in animals that such drugs can cut cholesterol levels in half.
And we were big proponents of the statins from the day we found out about them, and helped to guide Merck in their development.
Physicians were very skeptical about cholesterol-lowering drugs because 15 years earlier, the most effective cholesterol-lowering drug that ever been seen, actually it's as effective as the statins, it works at a different place in the pathway, led to the accumulation of an abnormal cholesterol-related sterol that caused cataracts. And this was not picked up in the initial clinical trials.
Believing strongly in the value and safety of statins, Brown and Goldstein recruited Dr. Scott Grundy to UT Southwestern, in part to perform clinical tests on the newly developed medication. A world-renowned expert on cholesterol metabolism, Grundy helped convince the Food and Drug Administration to approve small-scale clinical trials in Dallas. He then closely followed subsequent large-scale trials in Europe that produced convincing results.
We had no idea whether the results were going to be positive or negative, so it could have gone either way, I guess like a big election. But we sat in that room, and when these results were presented, then there was no doubt. They were so dramatic, and all of us were thrilled that the statin drugs were so powerful and so safe that it was just an amazing event.
Today, more than 30 million people worldwide safely take statins to control cholesterol. Countless lives have been prolonged by their use, and countless more will be saved in the future, traced in large part to the work of Brown and Goldstein.
Back in the old days when we used to do the experiments with our own hands, and you'd stand around a machine that was reading out the results, and you'd see the results slowly coming out of this machine, literally on a tape, and you'd get a spectacular result. The two of us would look at each other and we'd start babbling and immediately planning the next experiment and realizing, we just knew, the two of us knew what that meant and what a breakthrough it was. We didn't have to tell anybody else. It wasn't necessary for us to impress the world. We were trying to impress each other. A lot of scientists, once they make a discovery, will be running down the hall shouting about it or calling the newspaper. We've never had a press conference. Well, we had one when the Nobel Prize was announced.
And I got a call one day indicating that the boys did it. And I said, who is this? This is Ralph. I said, where are you? He said, I'm in Stockholm. Mike and Joe won a Nobel Prize. So I said, that's fabulous. Do they know about it? He said, no, not yet.
So we were at a meeting in Boston, Mike and I, at MIT. And by chance, he was in this hotel room, and I was in this one, and there was another hotel room here.
My room rings, and I pick it up, and it's a woman's voice, and she says, is this Dr. Brown? And I said, yes, in a very groggy voice. Well, how do you feel? And I said, what are you talking about? She said, well, how do you feel? You know, what's your reaction? And I said, sorry, I don't know what you're talking about. She said, well, I'm calling from the Reuters news service in Washington, and it's just come over the wire that you and your colleague, Dr. Goldstein, will share the Nobel Prize.
The New York Times and Wall Street Journal all had scientific correspondents in Boston. You know, they all wanted interviews.
One of the people said, now, when are you going to come out and make a statement? And I said, well, you know, we don't want to do anything in Boston. We did all our work in Texas, and we want to go home to Texas.
Well, Drs. Goldstein and Brown have just returned from Cambridge, Massachusetts, where they were attending a conference. And at this hour, they're meeting with reporters at the UT Health Science Center here in Dallas, where we're seeing this live picture. At a similar news conference earlier today on the MIT campus at Cambridge, the Texas researchers said that they were, in their words, overwhelmed by the honor.
I don't believe that the work that Joe and I have done could have been done in any other institution, because no other institution has the combination of assets and people that have made it possible for us to do a kind of research that spans a very broad field of endeavor.
This work was done in Dallas. It wasn't imported, by two individuals who got most of their, and in Joe's case, almost all his undergraduate education here. So this was a complete local product from start to finish.
UT Southwestern's Dr. Helen Hobbs, one of the world's leading experts on heart disease genetics, was a young researcher in Brown and Goldstein's lab when they won the Nobel Prize.
I heard it on the way to work. I was listening to NPR, and I heard that they had won the Nobel Prize. And of course, we were all really excited.
Well, the first thing they said was that a couple of scientists at the UT Health Science Center had won the prize, and my first thought was, gee, I wonder who that could be.
Dr. David Russell is the Vice Provost and Dean of Research at UT Southwestern. In the mid-1980s, he was a young researcher in the Brown and Goldstein lab.
There was an electricity in the air, but Mike and Joe weren't here.
They came back, and what I remember was drinking champagne in our library. And everyone was just thrilled and excited, and of course everybody was sending messages from all over the world.
The Nobel Prize was such a, oh my God, incredible thing to get. I mean, it was like, Nobel Prize, you almost never even met a Nobel Prize winner.
I did not sense that the Nobel Prize changed them in any way.
The atmosphere didn't change a bit, and in fact, so if the prize was announced on a Monday, and there were some celebrations, and we had a celebration in Gooch, I think, that afternoon. On Tuesday, we had a group meeting, and you couldn't tell that anything had happened at all. There was absolutely no change in the environment in the labs. People went about their business. There were all these experiments yet to be done. We were at a time when we had all these results, and it was a time when findings in the laboratory were increasing at an exponential rate. And so the prize came along not at the peak of those experiments or after they'd already happened, but right when they were just getting going. And so there was all this work to do, and I think that just focused our attention on laboratory work and not on the winning of a prize.
More than a quarter century after their Nobel Prize, the Brown and Goldstein partnership still endures. What is it about the two scientists that has enabled their partnership to flourish, well beyond the lifespan typically seen in the scientific world?
Well, I always say that a partnership to be successful requires that one of the partners, but only one of the partners, be a saint. Because if neither one is a saint, they're going to be fighting all the time. If both of them are saints, they're going to be too polite and they're not going to criticize each other and nothing will happen. So if you can't have no saints and you can't have two saints, the only other possibility is that one of the partners has to be a saint. And I ain't a saint.
There are two occupational diseases of collaboration, and one is astigmatism, and that's when the two partners don't see eye to eye. And if you don't, you can argue about, we argue all the time about details, but if you don't see eye to eye on the big picture, then it'll never work. And then the second one is egotitis. If two people have big egos, they often do clash, especially when one of them will end up with a bruised ego more than the other, especially if in a partnership, if one tries to take credit more than the other. So we worked this out many years ago where we don't take credit for anything because there's no way to really trace back the origin of an idea.
Looking forward, it's not just Brown and Goldstein's life-saving discoveries that are an important legacy. Their work ethic, intellect, and devotion to science have carried over into succeeding generations of scientists. Over the years, Brown and Goldstein have trained more than 150 graduate students and postdoctoral fellows, 5 of whom have been elected to the U.S. National Academy of Sciences.
You spend at least an hour a week with them in a group. So they have group meetings. The group meetings are organized based on thematic areas where they're working, and you present all the data from that week. I mean, I learned, and everybody learns who goes through their lab. You really learn what a good experiment is. And the other thing you really learn is how to present data. They are masters at presenting data.
When a student is doing their PhD thesis, they usually have a single mentor. But in our case, we're joint mentors for all the students. Same thing with the postdoctoral fellows. We don't have our own individual postdoctoral fellows. They work for the two of us. They quickly learn that they have two people that they've got to please and get suggestions from, and it works out.
Dr. Russell DeBose Boyd was a postdoctoral student in Brown and Goldstein's lab beginning in the late 1990s.
Well, disagreements between Dr. Brown and Goldstein didn't happen that often, but when they did, a lot of times, as I said earlier, you have to almost do both approaches, because science is not, in some cases, is not absolutes. Sometimes there's not really one answer to every question, and a lot of times you have to address a question by performing multiple experiments. And so, on the surface, it may be seen as a disagreement, but actually it's actually two different ways to answer the same question. And in many cases, both of those ways are very important.
One of the most destructive things in science is competition and paranoia. Once that happens, once that infuses a scientific community, then you don't have the kinds of open discussions in which you can discuss your data, share your data, explore your data with other people. And that's something that they've always maintained in our department, actually in most of the school. Doors are open.
The strongest lesson that I learned from Mike and Joe had to do with integrity in science, and had to do with how you do an experiment. And that was, there's sort of two different kinds of scientists in the world. There are those who will do 100 experiments to prove an idea that they had is wrong. And then there are those who will try 100 experiments to prove that an idea that they had was right. And the correct way to do science is the first one. And that was the approach that Mike and Joe took, the sort of philosophy of science. They didn't try to prove themselves right, they tried to prove themselves wrong.
As for the future of cardiac care, will Brown and Goldstein's work still carry relevance?
They wrote a little editorial type piece, which I think was titled "Coronary Artery Disease Gone by the Century," hoping that the disease would be gone by 2001, but it didn't quite turn out that way. They were a little bit over optimistic, but they recognized that we were on the way, and I think that's true. We used to treat high cholesterol levels and get them down from, say, 180 LDL, from down to 180, maybe to 150, and we'd be self-congratulatory. Now we can get them down to 70, but we haven't had people treated with this intensity at an earlier age. If we treated them when they were 30, I think we'd see, instead of a 30% decrease, maybe a 60 to 70% decrease in heart attack rates.